Hey folks, this is the section on 11.3 with the terminology and some theorems thrown in. First term that I'd like to look at is vertical angles. Vertical angles are going to be created by intersecting lines, always by intersecting lines. This is going to be a pair of angles whose sides are two pairs of opposite rays. So you'll notice here that the angle 1 and the angle 3, these two are vertical angles. If you can imagine a pair of scissors is the perfect example of vertical angles. Next, we'd like to talk about theorem 11.1, and this says that vertical angles are always congruent to each other. We noticed this when we had an activity in class where we were measuring vertical angles and we found that they were always congruent. Transversal. A transversal is simply a line that's going to intersect two or more lines, usually two other lines. So we would look at this line right here as my transversal. It is crossing over two other lines. If you would skip down then to the next theorem, which is going to be theorem 11.2. Theorem 11.2 in your textbook is all one theorem, but I decided to break this up into two separate theorems. So theorem 11.2a says that if any two parallel lines are cut by a transversal. Before I go any further than that, I'd like you to notice that that appears to be my picture right down here. Looks like I have two parallel lines, and it looks as though it's cut by a transversal. Then what you're going to know, if you have that, then your corresponding angles, your alternate interior angles, and your alternate exterior angles are going to be congruent. Now I know I have not defined those terms for you, but we will be talking about those in class. So just for now, know that if you have two parallel lines cut by a transversal, these three pairs of corresponding alternate interior or alternate exterior angles are going to be congruent to each other. The second half of this theorem is the reverse. So this time it says, if you have two coplanar lines cut by a transversal, and if you know that the corresponding angles, the alternate interior angles, or the alternate exterior angles are congruent, then you will automatically know that the lines are parallel to each other. So it's just the backwards version of theorem 11.2a. Theorem 11.3 says that the sum of the measures of the interior angles of any triangle is 180 degrees. I'll leave that one as is, and I'd like to talk about that one a little bit more in class. So continuing on then with theorem 11.4, we see that the sum of the measures of the interior angles on the same side of the transversal and formed when two lines are parallel is going to be 180 degrees. So if you'll take a look at one example here, angle 4 and angle 6, these are both interior angles and they're on the same side of the transversal and my two lines are parallel. When I meet all these requirements, those two angles, their sum will be 180 degrees. We know that this is also called being supplementary. The last theorem for this section is going to be theorem 11.5. The sum of the measures of the interior angles of any convex n-gon is going to be 180 times the quantity n minus 2. So an example of this might be if it's a hexagon, I know that that has 6 sides. So my n value then is 6. So that's going to be 180 times 6 minus 2, or 180 times 4. So that's the idea for theorem 11.5.